this video, I'll be making an MFT style worktop without using a CNC or any expensive specialist jigs or guide systems. I have full plans and cut lists for this table to complement this video, and they are available free to those supporting the channel on Patreon or at a small fee on my Etsy store. Links to both of those pages are in the description box below. So in my previous video, I made a table base using some reclaimed pine, and now it's time to make a top for it. I'm going to be using some 18mm thick moisture resistant MDF to make the top. I chose moisture resistant just in case I ever spill any liquids on the tabletop, as I wouldn't want the wood to swell if it gets wet. And I chose MDF rather than plywood, mainly because it was less expensive. Good quality plywood is very expensive. This sheet of MDF was about a third of the price. The very first thing that I did was to check the corners for square using my framing square, which I know is accurate. Sometimes factory cut edges are not as square as they should be, so it's always worth checking for projects where accuracy is important. I checked all four corners and marked up the corner that I liked the most. It looked perfectly square, so I'll work from that corner as my reference corner when I start to mark up the hole positions. I want my tabletop to be 1800mm long by 800mm wide, and here I'm measuring and marking up so that I can cut it to size. Obviously, I'm making sure that my reference corner is still on the sheet. I used my track saw to cut away the waste, and I did a lot of double checking of the measurements because accuracy is important on this build. With the top cut to size, I brushed away any dust and then started to apply some finish. It seemed like a good idea to get it on before drilling the holes. I'm using some water-based varnish, which is pretty much my go-to finish when I want something hard wearing. It's really good stuff. There are some links to my favourite finishes in the My Tools section of the description box below if you're interested in seeing what I use. While waiting for the finish to dry, I started making a simple drilling jig that's going to help me to drill the holes accurately. My jig is going to be made from a scrap of 18mm MDF. The stuff I'm using here has a veneer on it, but I'm just using that because it's what I had to hand. I started by ripping it to exactly 200mm in width at the table saw. And before I made this cut, I made a test cut on another piece just to verify that my table saw was cutting accurately, because it was really important that it measured exactly 200mm. And after making the cut, I verify it with a tape measure that I trust for accuracy. Then I could cut it to length, and I made my jig 800mm in length, which is the same measurement as the width of my tabletop. I made that cut using my track saw with my speed square guiding the cut. And again, this is a speed square that I know is accurate and reliably square. You might be wondering how I know that my squares are square. There's a really easy way to check this. All you need is a scrap piece of wood with a perfectly straight edge on it. Hold the square up to the straight edge, scribe a line, and then flip the square over, scribe another line, and if your square is square, those lines should be exactly the same distance apart from one another. As you can see, this one is spot on. This combination square, however, is not very accurate. It used to be, but now it's out of square, and I can demonstrate that by doing the same test. Here you can see the lines are not an equal distance apart. I don't really use this combination square as a square anymore for that reason. I do use it for other things though, and you're about to see that. So with that combination square, I set the fence at 100mm and then locked it down nice and tight. And I'm going to use this to find the center point of my jig by making a cut mark with my marking knife and then flipping the square. If the blade fits right into the same cut mark, like it does here, that verifies that it's the true center point. If it doesn't, you can adjust the combination square until it does. The knife mark is difficult to see in this footage, so I use my pencil just to highlight it for the camera. Now I know that I have the combination square set to the center of my drilling jig, I scribe a cut line with my knife down the length of the jig. Next, I offer up my steel ruler flush with the end of the jig, and I make knife marks along that center line every 100mm, again making sure to get it as accurate as possible. It's a good idea to clamp the ruler down so that it doesn't move, but I didn't bother, I was just extra careful. So I'm going to be using a 100mm spacing from center to center between the holes on my MFT style top. That is slightly different to the spacing used in the MFT tops by Festool. I understand that they are at 96mm spacing from center to center, but I did a bit of research on that and I can't find that there's any compelling reasons to use a 96mm spacing. All of the MFT accessories that I'm aware of will work on a 100mm spacing, so that's what I decided to use just to keep things nice and simple. It's a lot easier to use 100mm because A, less maths involved, and B, it's easier to read 100mm incremental markings on most tape measures and rulers. Next, I used an awl to press a hole right where each of the 100mm knife marks met the center line. These holes are going to make it much easier to locate a drill bit accurately at each of these increments. To drill the guide holes, I'm going to be using a 4mm brad point drill bit. I chose 4mm because that's what the shaft of my awl measures, and that's important for reasons that will become apparent a little bit later on in the video. I chucked it up in my pillar drill, and this is the first time I've used the pillar drill since I moved workshop recently, so I wanted to make sure that the table was square to the bit in case it got knocked when it was moved around, and sure enough it was out of square, as you might just about be able to see from this footage. So I loosened the bolt of the table, squared it up and tightened it again, and then it looked much better. So then I drilled out all of the holes, making sure to locate the brad point in the holes made by the awl to get them accurate. The drilling jig was now ready to use, but before drilling the holes, I denibbed the first coat of varnish on the top using some 400 grit abrasive paper, brushed away the dust and applied a second coat of varnish to really seal things off nicely. Once that coat of varnish was dry, I could start marking up for drilling the holes. My combination square was still locked to 100mm, having used it to scribe the center line on my jig, and I could use that to mark up 100mm in from my reference corner of the tabletop along both the long and short edges. Those lines are pretty difficult to see again, so here they are. So those lines should be at a perfect 90-degree angle because they are both 100mm in from my reference corner, which I know is square. But there was one more check that I could do to ensure accuracy, and that's using the 3-4-5 rule. If you don't know what that means, don't worry, it's not complicated, it's just a way of checking that an angle is at 90 degrees by measuring. If you draw a vertical straight line that measures 3 of whatever unit of measurement you prefer to use, and then you draw a horizontal line from the same point that measures 4, the distance between those 2 points to make a true right angle must equal 5. If it measures 5.1, your right angle is obtuse. If it measures 4.9, your angle is acute. But I wanted to scale up those numbers for greater accuracy. So if I double those numbers, 3, 4, 5 becomes 6, 8, 10. And then I put 2 zeros on the end. That gives me some dimensions in millimeters that I can use to check for square. But because my corner is set in by 100mm from each edge, I'm also going to add another 100mm to each of those figures, giving me 700, 900 and 1100. I can then measure in 700mm in one direction and 900mm in the other direction, and to check my corner was square, I could then line up 100mm on my tape measure with the first mark and measure the distance to the second mark, hoping that it would land on 1100mm, and it was spot on, so no further adjustments were needed. Next, I can simply line up my jig flush with the short edge at my reference corner and clamp it in place, and then using the 4mm drill bit in my drill, I drill out the holes. Not only is the drilling jig giving me accurate placement for each hole, but because it was drilled at the pillar drill, it's also ensuring that my drill bit is drilling the hole plumb. With all 7 holes drilled for the first row, I can then put my awl in the first hole, and this is why it was important to match the drill bit size to the thickness of my awl, and I can pivot the jig around until the edges are again flush with the edges of the table. I clamped the jig in position again and drilled the holes, this time down the long edge. Next, I could just work my way down the top row by row using my awl to locate the jig in the first hole. In this footage, I'm moving the jig from the second row to the third row, locating the jig with my awl in the first hole of the third row. I can then measure the distance between the short edge of the top and the jig on both sides to get it positioned accurately. So because here I am on the third row of holes, the measurement from the short edge to the jig needed to be exactly 200mm. I could then clamp it in position and drill the holes again. And then onto the fourth row where the jig needed to be positioned 300mm away from the short edge. You can actually line up the jig pretty effectively just by eye, because the edge of the jig should cover exactly half of each of the holes that were drilled in the previous row, if that makes sense. But I definitely recommend checking the distance between the short edge and the edge of the jig each time before drilling. And then it was just repetition until all of the holes were drilled. Originally I was just going to have 7 rows by 7 columns, and I was going to have the rest of the tabletop as just a regular surface, but I ended up changing my mind and adding more holes because I figured it'd give me more options in future. Next I could drill the holes to their full size, and I'm going to be using a 20mm auger bit to drill the holes because that's the size of the dogs and accessories that I'm going to be using, which I'll talk about later in the video. This auger bit set is by Irwin, and you can find links to it in the My Tools section of the description box below if you're interested in checking it out. This isn't an advert or anything, I bought them with my own money, but I've just been really impressed with them, so I thought it worth mentioning. It can be a bit tricky to drill large holes into MDF because as the drill bit bites into the layers of laminated wood, those layers can kind of tear, and that means the bit gets clogged up and stops biting into the wood to drill properly. The best technique that I've found is to switch the drill into its low gear so that it drills slower, and then apply plenty of downward pressure to the back of the drill to help the bit really bite into the MDF, and then drill the holes nice and slow. I'd also recommend just getting the hole started on the top side without going all of the way through, and then flipping the top over and drilling through from the bottom. That leaves a nice clean finish on both the top and the bottom. Next I use a chamfering bit in my router to clean up the freshly drilled edges of each hole. You can see in this footage there's a bit of tear out, and the chamfering bit tidies that up nicely. The edges of the MDF tabletop aren't very hard wearing, so to make it more durable, I'm going to be adding a hardwood trim, and I have some pieces of 18mm mahogany beading. The stuff I have isn't particularly straight though, as you can see. I decided to mitre the corners just to make it look nicer, and then I glued and clamped the pieces in place to force the wood back to being straight. And I used a few pin nails too, and I made sure to fire those nails in as low as possible because later on I want to add a roundover to the top of the trim, and I don't want my roundover bit to hit any of those nails. The pieces I had weren't quite long enough to do the long edges of the tabletop, so I mitered some joins too. This is just a nicer way to join pieces that aren't quite long enough. Looks much nicer than a butt joint would. I cleaned away any excess glue with a damp cloth. I was expecting to need to spend some time leveling the top shelf frame before adding the MFT top, but because I assembled it on a flat floor, it actually looked pretty good when sighting down the length. I did remove a few high spots though using a hand plane just to make sure that the top was sitting flat to the frame. I also broke over any sharp edges on the frame using a block plane to stop the edges from splintering in future. To secure the top, I'm going to be using pocket holes, but without using a jig. I just get the drill bit started and then slowly angle it and finish off the holes. I can then secure it in place from underneath with a screw long enough to grab hold of the MDF, but not so long that it would pierce the top surface. The trim was looking pretty good, but in a few areas it wasn't quite flush with the MDF, so I used a block plane to level it. And then I added a roundover to the top edges of the trim. This is going to make the edges more durable. Now I want to talk about a mistake that I made. When I designed this table in SketchUp, I made sure that the timber frame was well clear of the holes in the MFT top, both at the corners where the legs were and at the braces. But when I built the table, I completely forgot to position the bracing pieces as per the dimensions on the drawing, instead spacing them out evenly without thinking properly, so that was stupid. This meant that when I fitted the top, some of the holes were sitting right on top of the braces. So I had two options. I could either try to remove and then move those bracing pieces, taking out the screws and hitting them with a hammer to try and break the glue joints, or I could just drill out the holes through the timber instead. and I opted for the latter option. I'm not entirely sure right now if that's going to be okay with the accessories that I use in future, so I may end up removing and reinstalling the bracing pieces based on the dimensions from my original drawing instead, but at this stage I've never even used an MFT table, so I'll give it some time and see how it goes. Finally, I want to talk briefly about the MFT accessories that I plan to use going forward, and here they are. All of these came from benchdogs.co.uk, a UK-based company who design and manufacture these. I found out about them through one of Peter Millard's 10-minute workshop videos. I'll link to that video below, and also a video on the Bisch Basch Bosch channel, which I'll link to below too. You should definitely check out both of those channels if you're not already familiar with them. Both those guys are seasoned MFT users, unlike myself, as I'm very much a noob. Anyway, these dog and fence accessories are really nice quality and very reasonably priced too. Here I have a 1 meter fence with some flippy flag stops for repeatably accurate cuts. And if my top is truly accurate, which it should be, I should be able to now position this anywhere on the top. And that seems to be working, which is nice. Then I have these top protectors which I can install to create an air gap between the blade of my track saw and the tabletop so that I don't cut through it. And dogs of various sizes, and these come with collars too, and those are showcased in the videos mentioned earlier by Peter and Bisch Basch Bosch. Those are going to be really handy, and I also have some guide rail dogs which slot into the guide rails of the track saw. I'm mainly going to be using the MFT top for cutting down sheet materials, being able to make square and 45-degree cuts quickly and accurately. I still need to familiarise myself with everything else that an MFT table can do. There's probably lots of stuff it can do that I don't know about yet. If you're an MFT user and you want to share any YouTube video links with me that will help to educate me, then please do. In terms of accuracy, this MFT top is going to be more accurate than I could ever need it to be. Certainly well within my levels of tolerance anyway. I hope you enjoyed this video, I hope you found it useful. Please subscribe for more weekly woodworking videos. If you'd like to receive early access to my videos, exclusive content, free plans and cut lists, and a name credit at the end of my videos, you can help to support the channel on Patreon. There's a link to that in the description box below. Thank you for watching.